Okay, welcome everybody. I decided to make a lecture, a small lecture actually, to cover problem number 9.14, the problem of T section that was given to you in the class. Now let me reiterate the objectives once again by reading the problem once again. We see we have to find out the moment of inertia of this complete T section about the horizontal and vertical axis passing through the center of gravity of the section. So that means first you have to identify the center of gravity of the section, which as discussed by us today comes out somewhere around here. And once you have identified the point of center of gravity, you have to actually draw two axes. Excuse me just a moment. Yeah. You actually have to draw two axes passing through the centroid of the overall area. So this is the centroid, and now you have to draw a vertical line or a vertical axis passing through the centroid, and we will call it as y, and you have to draw another axis horizontally passing through the centroid again, and we will call it as xx. Now, since both these axes are passing through the centroid, both of them are centroidal axis. And as mentioned in the question, passing through the center of gravity, horizontal and vertical axis. So this xx is the horizontal centroidal axis and yy is the vertical centroidal axis. So we have to find the moment of inertia ixx of the complete section, and again we have to find a new moment of inertia but about yy. The section is the same, the T section, but we have to find the moment of inertia of this T section about xx, and again we have to find the moment of inertia of this T section about yy. So two inertia values have to be found. And finally the question says also find the polar moment of inertia of the given T section. Now, as you know, polar moment of inertia is calculated perpendicular to the area of the given section. So our T section will have to be taken up like this. I am tilting the T section, drawing a new image so that you get the idea of the polar moment of inertia. So this is kind of an isometric view for you guys. So here is your centroid, and this is your y-axis, y. This is your x-axis. Both of them are lying on the T section itself, and then you will have to bring a perpendicular axis like this, passing through the intersection of these two and perpendicular to the area itself, and we will call it as ZZ. Now, as you can see, XX and YY are perpendicular to each other, and this axis ZZ is perpendicular to the area itself, and you make it pass through the point of intersection. So once you have a setup like this, you can simply say that IZZ is the polar moment of inertia. And in order to obtain the polar moment of inertia, all you have to do is apply the perpendicular axis theorem. So if you manage to obtain the value of Ixx individually and Iyy individually, then in order to find the polar moment of inertia, all you have to do is add these two at the end of the problem. And this will conclude the overall problem. So this is what we have to do. So in our problem, the first step is find the value of Ixx. Second step, find the value of Iyy. And once you have found this, find the value of the polar moment of inertia, that is Izz. So this is what we are going to do. So let us start our problem by drawing it here. So I will draw the image like this so that it is with all the dimensions that is needed. And since a T section is a composite section, we have to break it up into two areas. So it's convenient for us to break it up like this. We simply make an imaginary cut here. So now this is your area number 1 and this is your area number 2. And now let us individually demarcate the dimensions of these two rectangles which are comprising your T section. So looking at this image, the first area has a length of 10 centimeter and width of 2. So let us note it down. This is 10, this is 2. Now the width of your second area is again 2 centimeters, but the height is not given. The height given is of the complete T section. So in order to get this height, that is the height of the second area individually, all you have to do is subtract this height of 2 from the overall height of 10. So that brings us to a height of 8 centimeters. So I will note it down. The height of the second rectangle is 8 centimeters and the width is again 2. Okay. So these are the dimensional traits of our T section. And now what you have to do is, first of all, you have to find the centroid. And that part I'm not going to discuss in this problem because finding the centroid x bar y bar for any composite area has been already explained to you in previous classes. So you go through the previous lessons, previous lectures, and find the centroid of the T section. I will just give you a basic brief guideline to help you with this task. Whenever you see a symmetric section like a T, first of all, you find what is the axis of symmetry. In this case, the axis of symmetry happens to be the y-axis, passing through the midpoint of this side and midpoint of this side. Why is it the axis of symmetry? Because about this axis, if you take the left hand side and the right hand side, they are actually mirror images of each other. But for a T section, the x-axis can never be the axis of symmetry because the upper part and the lower part will never form mirror images because of the presence of this T part in the upper part and the absence of this T part in the lower part. So the axis of symmetry is the axis YY, which you have to select in such a way so that it passes through the midpoint of the bottom side as well as the midpoint of the upper side. So this is the axis of symmetry. So one thing is sure, that the centroid of this T section will lie somewhere on this vertical line only. And now you apply the methodology of finding the centroid using this as the reference axis. Now only a reference axis would not be sufficient. You have to select an origin for that. So it's always convenient to select the origin for a T section as the bottom midpoint of the lowest line. So you already know that the centroid is going to be somewhere along this axis. This is passing through the midpoint of the bottom line. So you simply take this point as the origin. So this becomes your x-axis. And now with reference to this origin, your task is to find x bar comma y bar. That is the location of the centroid. So in short, your task is to find how many centimeters above this origin point is your centroid. And I will just take out the answer from the textbook that is already available. And if you want to see how they have arrived at it, you can go through the problem in the textbook also. It's a solved example 9.14 from RK Bansal. So I will just give you the answer. The answer given is from this point the actual centroid of the entire area, the entire T section, is somewhere around here, and this is at a height of 6.78 centimeters. So if in conclusion you ask me what is the value of x bar y bar, the centroid, since the centroid is lying exactly above the origin, that makes the value of x bar equal to 0. And since it is 6.78 centimeters above the origin, the value of y bar becomes 6.78. So the answer to x bar y bar is equal to 0, 6.78 centimeters. So this task you have to accomplish before starting the problem of moment of inertia. So this is actually a big problem. And if this problem comes in your RTO exam, this will carry the maximum weightage of marks. And this is generally asked in your examination. So it is very important that you learn the stepwise structured procedure to solve such problems. And that is why I have made this extra video for you, so that even after reading from the book, if you have any confusion, you can look at this video, have a look at it, and you will be completely free of any confusion. So anyway, we have accomplished the first task. Since we had to draw the centroidal x-axis and centroidal y-y axis as indicated here. We had to draw these x-axis and y-y through the point where the centroid is lying. So the first task was to find where the centroid is lying, and that we have done. It is at a height of 6.78 centimeters above the origin. So this is the location of the centroid. Now let us proceed further. Now we have in our hands this T section with the centroid known to us. We are calling this as area number 1. We are calling this as area number 2. And this is the location of your centroid. This side is 8, this side is 2, this side is 2, and this side is 10. So area number 1 and area number 2 are already in our hands. Now, the first task is to find the value of Ixx. That means you have to draw an axis through the centroid of the overall area and name it as xx. And the task at hand now is to find the overall moment of inertia Ixx about the centroidal horizontal axis for the complete T section. And since my T section is comprised of area number 1 and then area number 2, so I can say that this total Ixx must be the sum of the moment of inertia of the first area about xx axis and the moment of inertia of the second area about the same xx axis. So what we have to do now is individually calculate I1xx, I2xx, add them together to get the overall moment of inertia about xx for the T section. So let us get started with this. I will take the T section once again, and let me draw it in a different way this time. See, I am drawing the overall centroid of the area with a dot and a circle around it. For area number 1, its own centroid I am drawing as a single dot. And for area number 2, that means this area, it also has its own centroid. And that also I am drawing as a single dot. Now, since this figure is symmetrical, so we all know that all these three centroids will lie on this vertical line. Okay. Now let me just introduce a few dimensions which are going to help us. The side of area number 2 is 8 centimeters. So there is no doubt that from the bottom edge, if I measure what is the height of the individual centroid of the second area, this will be half of 8, that is 4 centimeters. The location or the height of the overall centroid of the complete area was already found by us to be equal to 6.78 centimeters. So this is 6.78. Now what is the height of the individual centroid of the first area from the bottom axis? This is, say, this height from here to here, it is 8 centimeters because this side is 8 centimeters. Now we have to add this length to 8. Now since this side, this complete side of the rectangle is 2 centimeters, so this height will be 1 centimeter. So 8 plus 1 makes it 9 centimeters. So this height is 9. Now, what are we going to achieve with all this dimensioning? Let us see. This is what we are going to do. We have to first find out I1xx, then we have to find out I2xx. Add them together to get the overall Ixx. So how do we do that? First of all, let us set about finding the value of I1xx. So now I need the axis xx which is passing through the overall centroid. So I am not drawing the complete figure now for the sake of improving the clarity of the task at hand. I am simply drawing the centroid and the axis xx. And I have to calculate the moment of inertia of only the first area about xx. So I will draw only the first area, that is this horizontal rectangle. So this is some place above here. So this is the first area. So now in the current figure, we only have the axis about which inertia has to be calculated and the first area for which we have to calculate the inertia. Now please remember the sides are 10 and 2. So we have to find the moment of inertia of this area about this xx. Now this is a clear case of parallel axis theorem that we learned today. The individual centroid of this rectangle is here. So what I will do is, although it is not given anywhere, I will myself construct a centroidal axis through the centroid of the first area in such a way so that this axis and this axis are parallel to each other. So I have made a construction like this, knowingly, deliberately. And I will name this axis as G because this is passing through the centroid of the first area. So I will name this axis as G. So now we have two axes for this area. One is the centroidal axis G and one is a parallel axis XX. And we have to find the moment of inertia of this area about the parallel axis XX. So parallel axis theorem says that this first area will have a moment of inertia about Ixx equal to, first you calculate the moment of inertia of the first area about its centroidal axis, its own axis, and then you add the product of area multiplied by h square. And what is h here? H is the constant distance between these two parallel axes. And this can be found out from the geometry that we have drawn in this figure. So if I look at this image, this is the center of gravity of the first area individually. This is the location of the center of gravity of the composite. This whole height is 9. This height is 6.78. So what will be this height? This is our target h here. So this will be actually 9 minus 6.78. So this h is equal to 9 minus 6.78 centimeters. And now we have all the information that is required for us to find I1XX. Now see, I1G means inertia of first area about its own centroidal axis G. Now the own centroidal axis is cutting the side 2. It is passing through the centroid. So we can simply apply the standard formula of BD cube by 12 here. Plus, what is the area of this rectangle? 10 multiplied by 2, that is 20. What is h here? 9 minus 6.78 comes out to be 2.22. So I will square it because we have to square the height. Now, look at the rectangle and tell me which side will be selected as B and which side will be selected as D. If you are correct, your answer should be the side 2 will be cubed because side 2 is the one which is being cut by the centroidal axis G. So BD cube by 12 actually becomes equal to 10 into 2 cube by 12 plus the remaining things we will add here, and this I1XX should come out approximately equal to 105.23, and the unit is centimeter raised to power 4. Please find out yourself why the unit is centimeter raised to power 4. This is the unit of inertia of area. So we have found out I1XX, and in order to find out IXX, we have to additionally find I2XX also. So let us follow the same procedure to find the value of I2XX. Now we are going to find I2XX. The meaning of I2XX means the inertia of the second area about XX axis. Okay. So we will draw only the second area, which is the vertical rectangle. The dimensions are this side is 8, this side is 2. Let us put the location of the overall centroid here. This is the point from which our main XX line is passing. Let us put the location of the individual centroid of the second area. And as you know, this height was given as 6.78. And since the height of the overall rectangle is 8, so the height of your individual centroid will be half of it. So this is 4. And as you can see, if I make this line as the centroidal G axis, why have I taken this as the centroidal axis? Because again, this is a case of parallel axis theorem. I have to find the moment of inertia of this second area about XX line, and I already know how to calculate the moment of inertia of this area about the G line. So I draw a parallel line through this centroid parallel to this XX, and all I have to do is find the value of this constant distance h. What will this be? This will be simply 6.78 minus 4, that is equal to 2.78 centimeters. So now we have all the required items in our hands. So according to parallel axis theorem, I2XX will be equal to IG, sorry, I2G. That means moment of inertia of the second area about G axis plus area of the second area multiplied by the square of distance between the two parallel axes. So now putting all the values here, I2G Since this is the centroidal axis of the second area, we can simply apply the formula of BD cube by 12 plus area of the rectangle itself is 8 height multiplied by width 2, that is 16 centimeter square, multiplied by the value of h as calculated by us is 2.78. So this will be 2.78 square. And now, once again, the question that is posed before us is what will be the value of B and D for this rectangle? Now, see, since the centroidal axis is cutting the side having length 8, so this will be cubed in the formula. So we can simply substitute this as 2 into 8 cube by 12 plus 16 into 2.78 square, and this should eventually give you the value of 208.99 centimeter raised to power 4 approximately. So now you have individually taken down I2xx and I1xx. And as was discussed earlier, the overall moment of inertia Ixx will be simply I1xx plus I2xx. And this should come out approximately to be equal to 314.22 centimeter raised to power 4. So this is your first answer. Your task was, please remember, to calculate moment of inertia of the section about horizontal axis passing through center of gravity. So that is Ixx. We have already calculated Ixx. This task is completed. Now we will set out to find Iyy. Now in order to do that, we will draw the T section once again. We will draw the location of the overall centroid of the T section. We will draw the location of the individual centroid of first area. We will draw the location of the individual centroid of the second area, and we will draw the vertical y axis, now about which we have to find the moment of inertia. So again, this is area number 1, this is area number 2, and you have to find the overall Iyy of the T section about the axis yy. And since there are two individual recognizable areas involved in this, you can simply say that this inertia, the overall inertia, can be obtained by adding the inertia of the first area about y axis with the inertia of the second area about the same y axis. Now, in this case, it is going to be a little bit convenient and we don't have to apply any parallel axis theorem. Why? Because conveniently for us, this y axis is the centroidal axis of all the three areas. Which three areas? Since y axis is passing through the centroid of the first area, so it is the centroidal axis of first area also. Since this y axis is passing through the centroid, individual centroid of the second area, so this is the centroidal axis of second area also. And since it is passing through the overall centroid of the T section also, so this is your centroidal area of the T section also. So you can simply apply the formula that are available to you. And please let us remember, this side is 2, this side is 10. This side is 2, this side is 8 for the second area only. Now applying this, I can directly calculate I1 yy. I don't have to apply any parallel axis theorem because the axis is passing through the centroid itself for all the areas. So I1 yy, which is the moment of inertia of the first area about y axis. So that will be, since the y axis is cutting the line with 10 centimeter length. So this will be simply BD cube by 12 equal to, so the side being cubed will be 10. So this is 2 multiplied by 10 cube by 12 centimeter raised to power 4. And similarly, I2yy will be equal to, again we will apply the same formula, BD cube by 12 for centroidal axis, equal to, now in this case you see that the axis is cutting the side with 2 centimeter length, so 2 is going to be cubed here, so this will be 8 multiplied by 2 cube by 12 centimeter raised to power 4. Now you have this expression for I1 by y, you have this expression for I2 by y. You have to add them up together to get I by y, and eventually the answer I by y for this problem will be equal to 172 centimeter raised to power 4. This is your second answer. So you have already achieved two answers. This is also complete. Iyy is also known, Ixx is also known. Now just in order to find the value of Izz, or the polar moment of inertia as described in this figure, all you have to do is simply add these two moments of inertia. So when you add them up, your final answer, or Izz, or the polar moment of inertia, should come out to be Izz equal to Ixx plus Iyy. The overall answer is 486.22 centimeter raised to power 4. This is your third answer. Now, if you have understood this, then you should be able to. So, this was what I was speaking. Izz is the polar moment of inertia, and Izz is simply the sum of Ixx and Iyy. These you have individually calculated. You add them up, you get 486.22. Now, if you have any further confusion regarding this problem or the problems that I have already included in your practice, the set of practice questions, please let me know either by SMSing me or messaging me through the WhatsApp, or even you can leave a message on the classroom app. Or if you think you need more personal time, you can give me a call before 8 p.m. anytime, any day. Okay, thank you very much. And with this, we will conclude.